that's an example of a dipole bond. And I need to get back up what was up there. They're not always shared. Okay. And what you have down here is you can calculate these dipole moments, because really it's only a moment that it's polar and things are constantly moving. So we call it, I shouldn't say things, electrons are constantly moving. So we call it a moment. And they took a look at 4 different substances here. We've got HF, we've got HCl, we've got HBr, and we've got HI. Okay? And which ones are sharing, how the electron sharing is going on. What you'll notice is the electronegativity difference here. In HF, it's 1.9. That's pretty darn large. And we'll talk about what that means in a minute. In HCl, it's 0.9. In HBr, it's 0.7. In HI, it's 0.4. Okay? The next thing I want to show you, hopefully it'll all fit on here, is this little chart right here. Perfectly fits. If it's between 0 and 0.4, we have what we call a nonpolar covalent bond. 0 and 0.4. The only one that is between 0 and 0.4 here, as far as your electronegativity difference, is this one, which is HI, right here. So that one would be considered nonpolar covalent. If it's between 0.4 and 1.7, so HBr and HCl, these two are considered polar covalent. Okay? And if it's got an extreme difference, greater than 1.7, then that's an ionic bond. Okay? So this one is nonpolar covalent. So these guys are pretty much just sharing equally. Okay, they're sharing the electrons nicely over here. It's a nice little share. Okay. So what you'll end up finding out is, depending on how much they share, this side, being ionic, is positive. This side is negative. Okay? Over here, it's got a positive and a negative, but they're shared a little bit more equally. Okay? So both of these guys are sharing it. I'm sorry, that's wrong. That's backwards. I'm looking at my... On these two, you have a positive here, you have a negative here. You have a positive here, and you have a negative here. They are sharing, but it's still got a little bit of a charge. So something that, if something came by this that was positive, it would definitely be attracted to this negative side. Over here, there's positives and there's negatives, but they're pretty much equally being shared, the negative parts, okay? All right, so your assignment is to look over the sample problems for sections 1 through 4 in chapter 8. And, don't you love that there's an and this time? Start thinking about Lewis dot structures, okay? Not just Lewis dot structures for individual atoms, but for molecules, both covalent and ionic substances. We did do these last year. If you want to look ahead, you can look at section 5 for a little reminder of how these are done. And I'll see you tomorrow.